Chris,
Anna,
welcome to Sovereign Radio.
thank you for having me.
Why don't you tell our viewers a little bit about yourself?
I'm Chris. I previously worked as the architect of the IBC protocol for the Cosmos project, and now I'm one of the co-founders of Anoma and Namada.
Cool. I want to explore Anoma first. Tell us what Anoma is, what it does, what it's known for.
What is Anoma? So I think sometimes we are perhaps renowned for not giving a very clear answer to this question. Mm-hmm. You're just smiling knowingly. Yeah. No one will tell me. Right.
Although I will say this, some of the things you said back then we didn't understand and we're starting to understand a little bit better.
That's the goal.
So
that's the goal. Right. Yeah. We'll see. But to me, it often helps to zoom out on kind of the history of what's going on in the blockchain space. There's a lot of noise, there's a lot of technical noise, and a lot of the technical noise leads to great innovation, but it also makes it hard to see where things are going.
Yeah.
So to me, if you zoom out, there are kind of three stages of blockchain architecture. And the first two stages I think we've kind of seen already, and we're in the phase of the kind of coalescence of the third stage. And the first stage is what I'm going to call scriptable settlement. And scriptable settlement really just started with Bitcoin. Back in the days of Bitcoin, no one thought about programmability, no one thought about intents, no one thought about solvers, no one thought even about privacy, because it was just what was this crazy thing? Was it even going to work?
Yeah.
Bitcoin built, a surprising amount of there is a little bit of programmability in Bitcoin script, right? But there's one asset. The thing that the network allows you to do fundamentally is send that asset around. Mm-hmm. Maybe they're multi-sigs or a few different configurations, but it's just, the asset and the protocol are kind of very tightly coupled, right? And the second phase is what I'll call programmable settlement. And really, programmable settlement only came about with the advent of Ethereum. There were attempts before to build colored coins, different assets on Bitcoin, to build kind of some services around the protocol. This was before the days of Lightning, just a little bit more. But they really never took off. It was clear that Bitcoin, just by its design, treated all other assets and all other programmability built on top as a second-class citizen. And it was very hard to get both the kind of technical security and the user experience that you need in order to actually build something people want. So Ethereum came along and tried to build kind of, full, modular gas, Turing complete programmability on top of a distributed ledger, right? It's the same kind of decoupling the asset and the blockchain a little bit, right? So now people could make ERC20 tokens, they could make DAOs, they can make all of these kinds of programmable interactions, but still the essential thing that was going on was settlement. So, when Ethereum started out, at least you sent your transactions to the Ethereum mempool and they said what code the Ethereum ledger should run, right? They specify a sequence of imperative state transitions. They say, go to this contract, make this message call, add these balances, subtract these balances, then you're done, right? And over the years, when Ethereum started out, that was what happened. And I used Ethereum in some of the early days, and you sent your transactions to the Ethereum mempool. I think I ran the C++ implementation before it got deprecated. It had these really cool emojis on the command line output. Yeah.
Whoa. Which one came after that, after C++?
C++. It was C++. For a while, it was C++, Ethereum, and parodies.
So the Rust
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 Ethereum, which used to have this in-browser wallet interface. I thought it was really cool. I was sad when they ditched that project, But over time, it's become clear that users don't exactly want to specify transactions. They want to specify, kind of what they want when they use the system. Let's just say it in an abstract sort of way. And there's a lot of in between that happens. Often they need to find what we call counterparties, right? They have one side of an interaction. They have asset A, they want asset B. They're looking for, right. They're looking for an asset which satisfies some properties, but they don't know who's got the asset. And, one thing that's to me, really compelling about these kinds of distributed systems is that potentially they can help us discover counterparties programmatically, right? This is very new. So you could always, even with Bitcoin, you could say, I want to do a 2 of 2 multisig to atomically swap some things. But I need to go troll around some signal groups. I need to go to Wintermute. I need to go to the OTC provider to find my counterparty, right?
Yeah.
Counterparty discovery was still manual. And counterparty discovery wasn't, I don't think it's so much that Bitcoin and Ethereum were wrong or anything like that. They were just trying to solve a different problem, right? The original scope of what blockchains were doing just involved settlement. It just involved ordering transactions on a ledger, executing them, maybe, at most making the results available for verification by a light client, right? But users want something else. Users have what we call intents. And the term intents, I tried to look this up because I didn't expect it to become popular, right? And I was trying to figure out, okay, where did I,
Where did you first
I've used
use
it
it?
for a little while,
Yeah.
but I didn't, I didn't attach any import to it, right? I found the first time I used intent was in this short protocol description of Wyvern that I wrote. Wyvern, yeah.
Yeah.
Wyvern's like a still existent Ethereum DEX protocol. It was used by OpenSea for several years, and I mean, at the time, I just thought like, okay, well, why are people going to use blockchains? I mean, my friends who don't go to this conference, like, they will use the system because they want something, right? Coordination technology is only useful if you want to do something with someone else, right? And just doing something with someone else already brings to mind this concept of counterparty discovery, right?
Yeah.
So back then, I tried to build really what was kind of like an intent system on Ethereum.
So you built it as a smart contract.
Right.
So what was wrong with that though?
I mean, the smart contract worked, but it just didn't do everything that was necessary, right? So the smart contract, I mean, the EVM is not really designed for intents. It's designed on the basis of like, von Neumann VMs just designed to execute programs sequentially and handle like message passing between programs on, like on a mainframe computer, right? That was the original design imperative for these systems. And it's possible to, I would say it's possible to emulate intents on top of the EVM, and it works. But it's a little bit clumsy because the EVM imposes this kind of strict ordering requirement. So when you write transactions for the EVM, you include like the order of message calls. You say, start with this message, do this other thing, end with this message. And you can't give any, it's difficult to give freedom to the later system to make those decisions about ordering for you. Because usually what users care about is not global ordering, right? You're paying for more than you want most of the time, right? You're paying these really high gas fees to get a global linear order of all transactions when most of the transactions touch state that doesn't have anything to do with each other, and most of what the users wanted, potentially could have been satisfied in a different way.
So what comes next?
So what comes next?
That model.
I mean, in our view, it will be this kind of intent-centric world.
Yeah.
And an intent-centric world really, it tries to invert the problem. So rather than thinking about, okay, we have blockchains and building stuff on top of them, an intent-centric view thinks about users, and users have intents. And how do we the intents are like the boundary constraints of the system, right? So I think sometimes it's helpful to think about it spatially. If you think about the intents are like the circle at the edges, and the intents flow into the network. And in the network, there are a lot of there are operators, right? There are validators, there are solvers, there are gossip nodes, there are all these other nodes. And the intents kind of constrain and specify what they can do if we describe them well. But some freedom is also given to the operators to make some decisions. And that there's a tricky balance here between giving the operators the appropriate freedom, but also constraining that freedom. Because if they have too much freedom, then you see something like MEV, right? Then you see that because the preferences of the operators, right, are different than the preferences of the users. The users want, they want as much of asset B as possible, or they want at the very least like a fair swap price. But the MEV searcher wants as much money for them, right? So you see this kind of this divergence in preferences when the action space of these interior operators isn't sufficiently constrained.
And that, I'm guessing, is where Anoma lives.
Right. I mean, so we conceive of Anoma as an architecture.
Okay.
And let me define that by contrast. I think it will make it clearer. So Anoma is an architecture, not a blockchain. Okay. Now, we will at some point propose a genesis block for an asset, which could be used by people, but it's not like the whole thing is built to be neutral. The Anoma asset doesn't have any privileged place in the system, and it's not. We're not trying to get everyone to like inherit security from Anoma or something like this.
I see.
Like there may be
not like a hub and spoke. It's not like things aren't locking into Anoma as a blockchain.
Right.
Okay.
In particular, I guess we envision the topology of the actual consensuses that you want to run as determined from the intents. So let me maybe give an example to make this a little bit clearer. So if I'm in Paris and I'm trying to buy coffee and I need to swap maybe I have some atoms, privacy in Cosmos, right? I need to swap my atoms to euro to buy coffee. Then my intent is to swap atoms to euro to buy coffee, and I need enough security for like a coffee payment, right? I don't need a lot. So probably just by virtue of describing that clearly, the system can go look on my behalf, and it can check, is there someone in Paris willing to accept atoms and give me euros, right? And that it never requires leaving Paris. So, the latency for this interaction can be like 50 milliseconds, and you don't need to pay for some kind of global security that you just don't need in this case. And now maybe it's the case that someone, no one in Paris has euro and wants atoms. Seems unlikely, but it's possible. And then the system can figure out, okay, it needs to go search further and wider to kind of try and satisfy my intent.
I have a question about these the three steps you just gave. There is also like a change in the way that the kind of technology is built. So there's the UTXO state model. Do you imagine this looking like the state model, or is it something else?
Yeah. So maybe this is a little bit spicy, but I think UTXO versus account is actually kind of a false dichotomy. Like if you investigate. If you try and pin these systems down to their essence, make them as minimalist as possible or as modular as possible, you could say, and you defer the decisions about ordering to runtime, then you end up with something which is both. And whether or not, state is still segmented, right, like in UTXOs, but the segmentation of state is defined by the program and defined by the user and how they interact with it, right? So
do you think of then the Anoma system being a hybrid as well, or will you need to affect that level, or can you just borrow from what existed before?
I think you can emulate things on what existed before. You can emulate UTXOs on an account system. You can emulate account systems on a UTXO system. It just comes with some extra cost, and it makes it more complex to reason about what's going on.
But for the intent-centric, do you need a new model?
I think we need a new model, particularly as it concerns sort of security and or consensus security and information flow control. In that we need a way for users to specify these kind of the assumptions they're willing to make, the consensus providers they're willing to use, and the constraints they want to put on who gets to see what information, right, as a result of their interaction, their intent, their interaction with the system. So I think that requires some more expressive systems which are capable of capturing these things. Some of the differences are maybe implementation efficiency differences, like you can emulate things on the EVM. Those costs matter because they translate to dollars, right? If you're paying 10 times as much gas because there's unnecessary ordering going on, then a whole bunch of use cases for your system just become infeasible. So some of the differences are just implementation, and you could emulate it.
I want to ask you a question that folks might actually be asking. So you sort of mentioned Anoma and Nemata. Those are two different names, two different brands. What are each of those things? I think we have covered in a way what Anoma is. Why are there two? Right. Why are these two linked?
Right. Why are they linked, and why are we doing so many things at once? Great question. So just as there are three phases of blockchain architectures, I also think there are kind of three phases of privacy in blockchains. I think we started out in the phase, really with the birth of Zcash, where privacy was tied to an asset, and privacy was you chose between the different altcoins, as they used to be called, right? And some altcoin and the different altcoins were defined by their feature sets, right? So
feature set of Zcash and Monero was privacy.
Was privacy, exactly. I mean, Zcash literally was a fork of the Bitcoin code base, which added ZK snarks, which added privacy. They tried to change as little as possible. And I think that that credit to Zcash where credit is due, ZK as it exists today, and all of these ZK rollups, ZK systems, Anoma, Penumbra, Nemata, none of this would exist.
For sure.
Without the word Zcash. But I think that tie between asset and protocol choices has been very limiting, because people have to choose. They kind of have to choose both or neither. So either they choose to exchange their assets to ZEC, the Zcash asset, and they can get great privacy, world-class privacy on the Zcash blockchain today, but they have to hold that asset. And that asset is not necessarily what everybody wants for all interactions, right? People want many different assets, they interact with many different systems, they might want to use local currency and stuff like this, and Zcash just can't support that as it is currently designed and architected. So I think the second phase of privacy, which is the phase which we're still in, is one where privacy is a service. Right? And things like Tornado Cash and Nemata and I would say Penumbra fall into this phase, right? So here, privacy is not tied to an asset. You can take your existing assets from the existing ecosystems and move them somewhere to get privacy,
into
right?
A private environment.
It's a service. It's you can take the things that you have and move them into a private environment, which is still separate from the whole thing is kind of mostly transparent, mostly public.
And you might pay a small fee to do that.
Right, exactly. And you have to, you do have to choose between do I interact with dApps on Ethereum right now, or do I get privacy right now? You can move between them cheaply, but their cost is not zero, right? So we're still in that phase, and I think the reason we're building Namada is to help that phase progress further.
And what's
Right.
that third phase? Is it privacy from the ground up?
The third phase we think requires really a ground up re-architecture.
Yeah. Okay.
Where I mean, to me, honestly, I think it's hard to know how to play the memetics exactly, but privacy is not quite the right word. It's a very difficult word to use in the context of systems architecture because it doesn't actually describe a property of a system. It describes a property of an interaction relative to a person, right? Like, what is a private system? A system where all data is private to everyone is useless. You never want this. Like, why would you use such a system? It's like a magic box. You put stuff in and you can never get anything out.
I like this. It's sort of like you're seeing the nuance of that word.
Right.
Privacy is used a lot. It means different things in different places. And there's this gradient. And so maybe what is Namada's flavor of privacy?
Right.
And I'm guessing that is in that third phase, actually.
Right. I mean, maybe, so to situate things, the third phase, as we envision it, is one where privacy is a default, you could say, or where users specify, instead of specifying what they want to keep private, which is still true in a privacy as a service world, right? By default, your things are public, you decide what to keep private, right? In a privacy as default world, users decide what to make public, right? So, which seems like, that's how we interact in social contexts normally.
Totally.
Right? You don't make everything public to all of your friends at once. You say specific things.
And it should be made easy to make things public if you want to.
Right.
Yeah.
So no, I mean, we think about what Anoma does is, really programmable disclosure, right?
Ooh.
Things start as private and they, it's not even that they just start as local, right? The information doesn't need to go anywhere that you didn't specifically tell it to.
Yeah.
And then, of course, you want to prove to specific parties that you've done specific things. You want to prove to the validators that your transaction is valid.
Yeah.
You want to prove to your counterparties that they've been paid. You want to prove to the auditor that your accounts are in order, and you should be able to do all of those things, right?
But what is Namada?
What is Namada? So I think it's, phase one is still, most assets are still transparent, right?
Yes.
There's a little bit of privacy as a service available, but it hasn't yet been normalized. Let's put it that way.
Is that where Namada is?
That's where Namada
It's
is.
phase one.
Phase two.
Oh, it's phase two. Okay.
Namada is trying to normalize privacy as a service,
I got it.
right?
Okay.
And trying to kind of build some economic incentives around privacy that treat privacy as a public good. So privacy is a public good in the sense that, it's non-rivalrous and more or less non-excludable, but also that the more people use privacy technology, the more privacy everyone has.
For sure.
Right?
But people are, in this case, like in an environment, and they're going to opt into that space again.
That's right.
Okay.
That's right. And that will still be true until we reach phase three. But what we hope to do with Namada is offer privacy as a service product that makes that opt-in costs as low as possible. Right? It's sort of designed to be one hop from the Cosmos ecosystem, one hop from the Ethereum ecosystem, and the privacy that you give to everyone by using a shielded pool on Namada is paid back in some sense in what we call shielded set rewards to people who are keeping their assets in the pool.
Going back though, Anoma and Namada, so both exist at the same time. How do they connect?
Right. So Anoma is like an architecture designed for the long term. And we want to be able to make the right long-term design choices because once you deploy a protocol, it's very hard to change, right? See, Zcash, Ethereum, IBC, everything has this property. But we wanted also to provide some assistance in bridging from phase one to phase three of this sort of three-phase privacy spectrum more quickly. Because if we end up, there's this like dystopia, right, where blockchains become this transparent surveillance nightmare, where there's now this like open intelligence market, right, on Ethereum called Arkham. There's, we need to be able to, it's not only that, Anoma tries to solve the long-term design question, but I don't think this is enough, right? We could solve the long-term design questions correctly, and like maybe the thing is live in 2 years and it's just too late, and everyone has decided blockchains are a surveillance nightmare, and, the regulators have imposed mandatory KYCs on everything, and we've just like given up, right? So we want to provide some incremental steps to help bridge them. And Namada is that.
I see. So it uses the Anoma architecture.
It uses parts of it.
Part of it.
Yeah. It doesn't, we wanted to ship Namada quickly.
Yeah.
And so Namada uses Tendermint, which Anoma will not use, and it uses it's not fully programmable. It just supports multi-asset shielded transfers and these shielded rewards.
After Namada, is there something like, do you have any sense for what the next stage, what would a third type of privacy product look like or network look like?
Right. I mean, maybe
You build it, or would somebody else build it?
I mean, I think maybe it's good here to make a distinction between the architecture and the primitives. So Anoma, the reason we've gone after this, like, what is
Middle.
architecture, right?
Yeah.
And architecture in some sense can be understood as a way of organizing things, a way of organizing components. So it's a way of organizing things like zero-knowledge proof systems, but as an abstract primitive, right? So the architecture is not tied to a specific one. So I think that we view our role is kind of helping with architecture and not optimizing the specific primitives. I'm not a trained cryptographer. I don't know what the newest thing in like efficient zero knowledge proof systems is going to be. But I'm hoping to build an architecture that is like future compatible with it by abstracting things properly. So I think it will be a collaborative effort.
Okay.
But maybe one other useful, I know in some sense, a way of understanding what Anoma is trying to build for interoperability of privacy is like private IBC. Which requires reorganizing a lot of abstractions.
Yeah.
The way IBC was originally designed just didn't have privacy in mind as an explicit design goal. And as in many other things, it's difficult to retrofit privacy.
For sure.
So, we hope to be able to offer a way of arranging things that allows for the properties people want, and then connect all of these specific and often modular primitives that optimize for specific things.
I want to bring us back to the topic of intents. You just mentioned that and defined it earlier, but like, what do you see an interaction between intents and rollups? Like, and why?
Right. I think this is a good question. And honestly, sometimes maybe it's just that I don't read everything, but to me, rollup is this like kind of fuzzy word where I don't always know exactly what it means. So I went to the Celestia glossary earlier this week to make sure I had accurate, up-to-date information. And Celestia glossary said, paraphrasing here, something like rollup is a type of blockchain that ultimately interacts with and inherits some properties from a layer one, at least data availability. Which I think is a good definition. It's like, it's clear. But the part in that definition that is a little fuzzy is a type of blockchain. What is a blockchain? So when we think about things in an intent-centric world, we start with intents and we do what we call solving. Solving means matching intents. So taking like A for B, B for A, you can match those together. But you can also do, and what we've called so far in our parlance, partial solving. Partial solving is where you take A for B and B for C and combine it into A for C. But I think this is a rollup. It's like an on-demand rollup because you're doing sort of compositional sequencing just on demand from the intents when you need it, instead of like when you use an application on a rollup, it's fixed to a specific rollup. It's like you fixed some of the topology of settlement. You're going to send your transactions to this application. That application is going to sequence them and execute them, and then it's going to like post data to Celestia or Ethereum, something like this.
Still a little lost on that connection point, though. Like you're saying, like you do this partial intent solve, but why not do that on a one, or like why what does that really have to do with the rollup environment? Is it because there's certain parts of its consensus have been kind of taken out?
I think maybe the advantage of such an approach is that it allows you to choose which rollups to use dynamically based on the intent. So
you're imagining multiple rollups then in this case. This is not all happening in a single one.
No, it's like rollups on
okay.
demand.
I see.
It's like take two intents, A for B, B for C, and just make a rollup. Like make a rollup, in the gossip system. Really, it's like completely ephemeral. But make a rollup, combine them to A for C, and then you could view this even if you have some final settlement layer. You just do this until you get a transaction, and then you post the transaction to the settlement.
I guess this is a really different way of thinking about rollups, though, because I always think of rollups as like a full-fledged blockchain, where there's a team and it takes months to do something like this. So like how would you be able to do it so quickly for a trade or for an intent search or matchup? I guess you call it intent matching.
Yeah. I mean, I think it's possible to standardize the protocol. So as I understand the space at the moment, it's not perfectly, but different rollups want to make different specific choices. Like they want to build different instruction sets. They want to build slightly different VMs. They want to optimize their storage for like such and such a purpose. And I think that's great. And we'll continue to see that kind of specific optimization. And Anoma comes at this from the perspective of making things compositional. So let's say there's like rollup software 1 with instruction set 1 and rollup software 2 with instruction set 2. And when you articulate things as intents, you don't need the instruction sets to be the same. They could be different.
Oh, wow.
Because you only check the results.
Okay.
Right? So I can take intent 1 that was formatted in the way of rollup 1 and intent 2 that was formatted in the way of rollup 2. And then the intents need to be able to understand the results of executions. There needs to be some like legibility at the state layer, but they don't need to agree on the instructions.
Is this almost like a rollup on those rollups that like just lives there for a brief second, does the combination and sort of spits back something?
Yes, exactly.
Okay.
Exactly. It's like, creating rollups when you need them.
What that looks like to me, or what it sounds a lot like, is a bridge between two rollups that does something, but I feel like you're not thinking about it. I mean, you're calling it a rollup. You're not calling it a bridge.
Yeah, I mean, I think it depends on, it hinges on, if we look at the definition of rollup that Celestia's glossary uses, it says a type of blockchain. So whether you consider it a rollup or a bridge kind of depends on this, like, what counts as a type of blockchain, right? That depends also on what you view the essence of a blockchain is, right? Sorry to dive into language here, but it's hard to like, so let's call this thing that I'm describing, let's call this like parallel sequencer composition. Okay. Right? So we think a lot about sequencing in rollup plan. And sequencers are making decisions about ordering.
On each rollup.
Right.
Individually at this time. Yeah.
Right. And because intents don't specify ordering, because they're kind of ordering agnostic, or at most they constrain it somewhat, this allows for parallel composition. I think it might be helpful here to think about sequencing, something that rollup folks talk about a lot. And sequencers are making ordering decisions, but intents are purposefully agnostic to exactly how things are ordered. They specify at most constraints around ordering, but mostly they specify what someone has and what someone wants, right? They specify preferences. And this allows for intents that were sent to different sequencers to be composed. So we can say sequencer 1 takes A for B for C, composes it to A for C, and sequencer 2 takes C for D and D for A and composes it to C for A. Then sequencer 3 takes A for C and C for A and composes it to a transaction.
Is both, like it's basically combining them from that start point to that end point. Does it actually have to combine all the stuff in between to do that? Or does it sort of throw it out and just say, actually, we're just going to skip all of you?
Luckily, with sort of ZK rollup, basically, we don't need to reprocess things.
So it's been processed. You're using that, I guess.
Right, that's right. So when we do A for C, we've already figured out the stuff in between. And when we do C for A, we've already figured out the stuff in between, and now it's just one more step of composition.
Kind of going back to that, like, modular, like all those rollup. I'm just trying to picture like there's a lot of rollups all of a sudden. What does that do to like the economics, the center of gravity of one of these things? Like, are we just getting further and further away? Does it become like more dangerous, lower security? Yeah,
I mean, I think it will be very important in this world that we come up with good ways of describing security to users and enforcing those descriptions at the system level, right? So one danger, just with or one maybe warning with the modular stack as is kind of currently being deployed, is that users are using these systems with a bunch of modular components operated by different parties, and they are not going to understand the security assumptions
of each other.
Right.
And in this case, in this kind of architecture, like where is the center of gravity for data availability? Like, is it still in the middle? And also, like, if you get further away from that, does it affect security or something?
I mean, I guess I would understand data availability in this architecture is polycentric, that it's going to depend on what the data is, like what it means to users. If this is, data has some value, right? We can think of it as private keys that allow me to spend something or some kind of information about assets that we're deciding to keep on the ledger, right? And what that value is not defined by the system itself, right? That's like defined by the relation, by what 5 atom means or something to the world, right? So it's not something that I don't think it's something that we can entirely standardize or that should live in one place. It depends on what it means, what the user security assumptions are, how much they want to pay for it. Globally replicated data is more expensive, how much they care about latency. If you typically want data to be available in the sense that you might want to be able to retrieve it. In order to retrieve it, you need to physically contact the person who's storing it, and that's more expensive if they're further away, right? And also, I think it matters for resiliency that, like, you don't suppose that there was some global war, and like the global data availability provider got disrupted, or half their nodes went offline, or half of them are not allowed to respond to your requests anymore because of physical threat, or something like this. It would be really bad if your community's data was all only stored on this global data availability provider, right? So you always want like local backups and copies of the data.
So you do see it sort of fragmenting then.
Yeah, I see it more like you could also view it as like a distributed cache optimization problem with just additional constraints around security, like better tests and stuff like this.
Okay, I have a last question, burning question I've had. We talked about Namada in the context of these like 3 stages of privacy, but is Namada a roll-up?
Is Namada a roll-up? Well, I mean, the definition of roll-up includes something called L1. And I think maybe I have a slightly different view on what an L1 is. I think people think of L1 as like an architectural difference, that like some things are L1s and other things are not L1s. But if you understand L1 is also kind of meaning that this is the final root of trust or something like this, to me that's a decision that is observer dependent. It's like defined by the user, not only, and it doesn't have to be consistently defined by the user. It can be defined differently for different interactions. So when I'm paying for my coffee in Paris, I don't want to wait for the global L1, right? I want to wait for like the Parisian fast, 4x settlement roll up, right? Or something. So that's my L1, right?
Okay. So would Namada be a L4?
And Namada could be it could be an
Does
L1,
it hook
L2,
into something
L3,
else,
L4.
I guess is the real question.
I mean, at the moment, it does not provide like full recursive state proofs.
Okay.
It provides something, I guess comparable to like a multisig, and some L2s, some things that call themselves L2s just have multisigs. So in that
So
sense,
you could bridge over to something.
right,
if you
exactly.
needed to.
But in the future, Namada and certainly Anoma will have full recursive state proofs, and then you could say that anything is a roll-up of anything else.
But would it be an L1 instead? Things branch off it.
Maybe,
I guess
maybe. Both, right?
I mean, you really have, I can hear this, like you have very much the mesh view, right? Like that it's not center with a lot of things coming out of it, but much more like a mesh, with a lot of pieces bridging together, data availability, living everywhere. Yeah.
Yeah, I mean, I would say eventually, I think we're using these systems for economic coordination, and eventually I think the architectural topology will kind of be drawn to match the economic topology, and the economic topology very much is polycentric, right? And when it's too central, we run into trouble. Then we run into like global world government or, American empire or other shenanigans that are difficult to deal with because there's kind of one center and everyone's competing for control over it. So yeah, I'd say.
But do you at this moment in time, don't you feel like in the blockchain world, there's also sort of that? There is like the winners right now, and they won't necessarily be the winners forever, but it's like there's this period of like lots of different options, and then there's a winner, and then there's lots of options, and yeah.
Yeah, I mean, in some way you could view that kind of expansion and contraction as like a learning process or a selection process. Not that it's perfect, but they're periods of, what we call bull markets or something like this. You could call periods of experimentation.
Yeah.
And a bunch of money is spent on stuff that's like not going to work, frankly.
But some of it is good.
And you don't know until you try, right? And then bear markets right now are this phase of contraction.
Yeah.
And the phase of contraction is painful, especially if you are not, and there's lots of luck involved, there's skill and luck, and not everyone's going to be both lucky and skillful all of the time, right? But on the other hand, it's necessary to kind of not waste too many resources and just to clarify what's going on.
Yeah.
Because like the sort of the group of people and the distributed consciousness are forced to come back together and kind of reckon with what are the relations between all these different experiments. So I think you see this now, actually, in this particular cycle.
For sure.
That there's this sort of like architectural convergence where, you see it in Ethereum dexes like Uniswap, CowSwap, 1inch are all basically building the same, like slight variations on the same thing. I think you see it in kind of the modular architecture and ten-centric architecture approaching each other from different directions, sort of bottom up and user down. I think you see it in a lot.
I wonder if the experimentation has just moved somewhere else, though.
Maybe
Different parts, like, or are we only in an optimization phase where we've decided or sort of come together around ideas and now we're optimizing those ideas? Or is there like, yeah.
I mean, I think there's also a lot of, these systems actually work in practice. A lot of the necessary experimentation is not technological or not solely technological. It's also cultural. And I think we're only at the beginning of that phase. Like DAOs mostly don't work, right? But there's a lot of good experimentation.
Yes, absolutely.
And the good experimentation seems to be, at least sometimes, like congealing into replicable practices or languages or sort of patterns of organization that are at least somewhat different than corporations. And that, for someone's definition of work. So
cool.
I think lots of that to come.
Thanks, Chris.
Thank you.
Thanks for coming on Sovereign Radio. And thank you all out there for watching.